In this video, I'm going to show you how to solve a system of equations from a word problem. And so just the step that would make this a little bit more challenging is that you have to come up with the equations yourself. And so I want to walk you through how to do that. So the question says the admission fee at a small fair is $1.50 for children. Children are going to be called C in the problem. And $4 for adults. And we're going to call adults our capital A. Now, on a certain day, 2,200 people enter the fair, and $5,050 is collected. How many children and how many adults attended? Write a system of equations that will model your problem. Now, when you think about the types of equations that we've learned so far this year, one of them looks like this: y equals mx plus b. And in order to use this equation, you need to know slope and a starting point. And the numbers that we were given here do not represent slope, and neither of them said an initial fee or a starting fee. And so I'm not going to be able to use this equation. Another equation we've learned is y minus y1 equal to slope, and then times in parentheses x minus x1. Now for this, we need to know one point, which we were not told, and we need to know slope, which we were also not told. And so the only other equation we have left is standard form, which is ax plus by equal to c. So this would mean you know an amount of x and you know an amount of y, and together they make some total. And we know that for both scenarios, actually. Our money for children plus the money for adults equals the money total collected. And so that's going to be one of my cost equations here. So where you see cost, I'm going to put the dollars. So $1.50 per child plus $4 per adult, and that equals a total cost, which was $5,050. And then the other equation that we have is the total number of people attended. Well, if children attended and if adults attended, and I'm adding the number that attended, that will equal 2,200 or 2,200 people. Now, these two equations are what I'm going to use to solve for my system. So I'm going to take a look at what we have and just kind of align my terms. $1.50 for C plus $4 for A is equal to $5,050. And then C plus A is equal to 2,200. Now what I'm going to do to solve this system is use substitution, and I'm going to solve for the C in this equation by subtracting that A to the other side. So C is going to equal 2,200 minus A. And then what I'm going to do is substitute this expression right here into the C of the other equation. So it looks like my yellow is a little hard to see, so let me switch colors here for us. So this expression is going to get subbed into the C of the other equation. So if I substitute here, it's going to look like this. $1.50 for the expression of C plus $4 for A equal 5,050. And now what I'm going to do is distribute my $1.50 to each of these two terms that's in parentheses, and then I'm going to solve for my A. So $1.50 times 2,200 is going to give me 3,300 minus $1.50 A plus $4 for A, and that equals 5,050. Now what I'm going to do is combine these two A terms here. So 3,300. Now 4 minus $1.50 would be $2.50 for A, and that will equal 5,050. Now what I'm going to do to solve for A is subtract my 3,300 on the other side. And then I'll isolate my A term here. Okay, so 5,050 minus 3,300 is 1,750. And now if I divide by that 250, which was my coefficient in front of my A, I will have 700 adults. Now the total number of adults here, if I know is how many adults went to the fair, then I can solve for my C because the adults plus the children should equal 2,200. So if I use, now I'm simply just plugging A back in, and really you can plug it into either equation. So if A is equal to 700, children plus 700 adults equals 2,200 total people that went to your fair. So now I'm going to subtract 700, and I'll get the number of children. So 2,200 minus the 700 adults will give us 1,500 children. And that is my answer, adults and children.